Welcome everyone, this is Tom. Today I will show you how I designed and implemented an application-to-application communications through cloud-based real-time notifications and messaging. I'll walk you through my architecture and show you a demo. Staying in sync. In today's fast-paced world, users rely on multiple devices and expect seamless synchronization across all of them. But what if you need to build a system that ensures real-time communication and synchronization between different applications running on various devices? The challenge is keeping data consistent across platforms nearly instantaneously. How do you achieve this? Thanks to modern cloud technologies, creating such a system has become remarkably straightforward to implement and deploy. Technology. One of the key cloud technologies that makes it easy to build applications where client and server need to exchange data in real time is the Azure Web PubSub service. This service facilitates the communication between a publisher and subscribers. That's the name PubSub. A publisher is a component that publishes or sends data updates. A subscriber is a component that subscribes to data updates to receive them. Azure App Service is a fully managed, highly scalable platform designed for building, deploying, and managing web apps and APIs in the cloud with minimal infrastructure overhead. In my solution, an ASP.NET Core Web API functions as a central hub, efficiently managing specific communications from clients. This architecture is designed for seamless scalability and adaptability, ensuring that it can grow with evolving demands and remains robust as the system scales and demand increases. Client applications can run on different platforms. The key technology enabling seamless communication in all these environments is the WebSocket protocol, which facilitates full duplex, low latency communication between the client and server, allowing real time data exchange and interactions across devices. Let's look at my high-level architecture. Shown on the left, I have three applications running on different devices. For example, when I perform an action on one of them, like send a message to a different person or manually refresh and download the latest data, I want all my other running instances to stay in sync and reflect that change as well. In my architecture, I use a web service as a central communication component which exposes a few REST web APIs that are called by my client application to send messages. When my web service receives a message via the web API, it ends up sending a message to my web PubSub for routing. In my controller action for my API, I only specify what hub that message needs to be routed to, and web PubSub handles the publishing to all subscribed clients. Certainly for demo, I didn't need this web API if I only wanted to showcase real-time notifications with Azure Web PubSub. My goal is to leverage my expertise to present a real-world, robust architecture and design that serves as a foundational building block for scalable solutions. This architecture is designed to grow seamlessly with evolving requirements, ensuring long-term flexibility, performance, and adaptability in real-world applications. In a real solution, your web service would certainly use a database to store user data, messages, or anything based on your requirements. There's also nothing stopping me from sending messages or events directly to the web PubSub service from my applications and bypassing the web service completely. You might choose to only send some key events via this channel, which in turn could start some server async processing or trigger a different notification to your applications, which end up calling your web service. Keep in mind the maximum message size to and from web PubSub is 1 megabyte. Thus, in my experience, having an application communicate with the web service offers many advantages. It allows you to introduce additional business logic, giving you full control over the request and communication flow, enables more flexibility in managing and processing the data before it's sent to the web PubSub service. And you can send and receive large amounts of data. Let's go over my detailed architecture diagram and data flow. On the left is a user that's running three applications on different devices. Towards the bottom is the web service that'll handle communications from applications and that can read and write data to a database. In the top part of the diagram is the Azure Web PubSub service that'll handle real-time notifications and messaging. The client application must subscribe to the Azure Web PubSub service to receive any messages published in real time. This subscription ensures that the client is actively listening for and able to respond to updates or notifications as they are broadcast by the service. Clients specify which hub and optionally which groups they wish to subscribe to in order to receive relevant real-time notifications. This process typically occurs during application startup or immediately after user login. For this demo and in this diagram, I chose my phone app instance to be the source or publisher of messages and the other two to act as receivers. When the phone app wants to send a message, it'll do so via my web service. Here I can perform business logic, perform DB operations, but in the end publish a message to the Azure Web PubSub. Part of that call contains additional metadata that directs it to a specific hub. Once the Web PubSub receives that message, it'll route it to the appropriate hub and broadcast that message to all clients that have subscribed to it. Subscribed apps will receive the message and process it accordingly. In my demo, I'll display the message, as each app will send back an acknowledgement, again via my web service. My web service does some minor data transformation, performs some minor business logic, and publishes to the appropriate hub that I configured to handle ACKs. The Web PubSub will route this message to the appropriate hub, which will broadcast it to all subscribers. In the end, my phone instance will receive this ACK and process it. A few things about my demo. For my different client instances, I chose to implement them as rich clients using WinUI. That allows me to run multiple separate instances on one PC. Individually, that will interact with Azure Web PubSub service and my Azure ASP.NET Core Web API service, both which I deployed to Azure. Let's look at how this works in practice. I have 3 instances of my WinUI application. The top one is acting as a phone or the sender of the messages, and I'll call this one Phone 1. The bottom left application, I'll call App 1, and I'll tie it to the Phone 1 notifications. And I also have a third instance of the applications, which acts as a receiver instance, and I'll call this the App 2. I'll manually subscribe for notifications by registering my phone app and my first instance with Azure Web PubSub. This is something typically done automatically at startup or after login. I have a field for an ACK message, which I'll change to show these messages are actually being sent back and forth. Let's send a message from my phone app. When I send this message, it'll go through my web service and Azure Web PubSub. I output that this message was sent. The receiving app got the message and responded with its ACK message. And we can see the phone app received the ACK message, which is displayed in the status messages. I'll register my second app instance in order to subscribe for notification. I'll change this ACK message, and from my phone app, I'll send hello to. You can see that once I sent that message, both of my applications below received it. They each sent their modified ACK message. In the phone status messages, you see both of those ACK messages were received. To show the solution can support separate communication groups, I have a new phone instance that I'll call Phone 2. I'll register it with Web PubSub to subscribe for its own notifications. I also have another instance tied to Phone 2, which I call App 3. I'll change the ACK message to differentiated. Now I'll send a message from Phone 2. Only App 3 receives it, and it sends back its unique ACK message, which only Phone 2 gets. This is made possible in large part by Azure Web PubSub, which provides the flexibility to subscribe to different hubs, each uniquely tailored to your specific requirements and notification needs. In summary, my demo showed how modern technology can be leveraged to address certain communication and notification requirements. It highlights the primary building blocks that can be used to build a scalable solution for real-time messaging. It's a solid architectural starting point that can be easily enhanced. It didn't cover syncing history, client and service storage options, multi-user and multi-device communication, and of course security such as authentication and authorization. All these components are essential for delivering a fully production-ready solution. However, with this design, you'll be already well on your way laying a solid foundation that brings you significantly closer to achieving a scalable and reliable system. Thank you for watching. I hope you found this video helpful.